If your brain freezes during CSEC graph questions, this is for you.
All right, let's jump right into the explainer. Today, we're basically unlocking a mathematical cheat code for your CSEC exam. We are talking about mastering coordinate geometry and linear equations. I promise you, by the end of this, those straight line questions that used to seriously slow you down, they're going to be an absolute breeze. So let's power up those math skills.
Right off the bat, I want to hook you with this absolute boss-level multiple-choice question pulled straight from the exam materials. It asks, the equation of the line which passes through the point 0, 5 and has a gradient of 4 is, and then it gives us a few options. Now, at first glance, you might think you need a whole page of scratch paper to work this out. But trust me on this, by the end of this explainer, you're going to be able to solve this exact problem in under 10 seconds. No joke.
Okay, let's dive into this. The golden key to this entire topic is the slope-intercept form. You've probably seen it, y equals mx plus c. Now, you really only need two main puzzle pieces to completely conquer these linear equations. First step is m, which acts as your multiplier. That tells you the gradient, or basically exactly how steep the line is. The second piece is c, which is your constant. This represents your y-intercept, which is just the exact spot where your line crosses that vertical y-axis. And honestly, that's it. Just two pieces to finish the whole puzzle.
So how do we actually use this? Well, I like to call this the plug-and-play method. It's just a really simple four-step core loop. Step 1, identify the gradient, your m. Step 2, identify the y-intercept, your c. Step 3, write out your base formula, y equals mx plus c. And finally, step 4, just substitute those exact values into the equation. What is so great about this method is that it strips away all that intimidating algebra. You literally don't have to overthink it at all. You're focusing purely on putting the right number in the right slot.
However, we do need to talk about a massive trap. Notice the really common mistake we're showing on the left side here. If the exam question says the gradient is 4 and the intercept is 5, students constantly rush and swap them. They end up writing y equals 5x plus 4. Please, do not let this be you. Instead, focus on the right side for the correct substitution, y equals 4x plus 5. You have got to always remember that m, the gradient, is always the multiplier sitting right next to the x. Just make sure to keep them in their proper lanes. Now, for a major speed run tactic that is going to save you some precious exam time, we call it the zero coordinate rule. If you ever look at a coordinate and the x value is 0, like 0, sk, then your c value, your y-intercept, is automatically just that k value. That's right, absolutely no extra algebra needed. If the line passes through 0, 5, boom, your c is instantly 5. It is literally just handed right to you. And we can actually combine that zero rule with a basic process of elimination to build an unbeatable multiple-choice strategy. Think about it. When a question pops up, first, scan for that zero coordinate to lock down your c. Next, check the options for the correct x multiplier, your m. Finally, instantly cross out any option without that exact correct mx term. By doing this, you can literally trash the incorrect options and select the right answer instantly. And you do all this before you've even picked up your pencil to do any real math.
But what if the exam doesn't hand you the gradient on a silver platter? Well, we just calculate m from scratch using rise over run. Simply subtract your y-coordinates to find the vertical rise, then subtract your x-coordinates in the exact same order to find the horizontal run, and just divide them. Let's apply this to a real C6 specimen paper example using the points -4, 3 and -2, 5. But a huge warning here. You must be incredibly careful with your negative signs and your subtraction order. If you start with 5 minus 3 for your y values, you absolutely must start with -2 minus -4 for your x values. Don't mix wrong.
Let's actually crunch those specific numbers. The rise is 5 minus 3, which gives us 2. The run is -2 minus -4, which really becomes -2 plus 4, also giving us 2. So we divide a rise of 2 by a run of 2, and we get 1. See? You've just proved you can find your m completely on your own, perfectly calculating that the steepness is exactly 1.
Now, what's really interesting about this slide is how we level up to some advanced tactics for perpendicular lines. Remember, those are lines that cross at exactly a 90-degree angle. If you need the gradient of a perpendicular line, you use the negative reciprocal method. Step 1, identify your original gradient. Step 2, flip the fraction entirely. Step 3, change the sign. So if a line is a gradient of 2 over 5, you flip it to 5 over 2, and then you just make it negative. So your brand new perpendicular gradient is simply -5 over 2. And you might be wondering, why does this whole flipping and switching thing work? Well, because it adheres to an unbreakable geometric rule. If you multiply the gradients of any two perpendicular lines, the product will always equal -1.
Let's test it out with our last example. If you multiply our original 2 over 5 by our new negative 5 over 2, you get negative 10 over 10, and that perfectly simplifies to negative 1. It's honestly a brilliant built-in way to verify you have the exact right answer while you're sitting in the exam.
And this brilliantly illustrates what happens when we take steepness to its absolute extremes. Let's look at horizontal lines first. They have a gradient of 0, literally no steepness at all, perfectly flat. Because of this, their equation simplifies to just y equals c. So a perfectly flat line passing through the point 4, 7 has the amazingly simple equation y equals 7. On the flip side, vertical lines have an undefined gradient. Why? Because calculating it would require division by a run of 0, which breaks math. Dropping straight down without moving left or right means their equation is simply x equals k. So a vertical drop through the points 5, 2 and 5, 10 is literally just the equation x equals 5.
All right, let's see how all of this builds back up to our initial obstacle. We are returning to the boss level question. The equation of the line which passes through the point 0, 5 and has a gradient of 4 is it A, B, C, or D? I challenge you right now. Apply that plug-and-play method and use that massive zero-coordinate rule we just learned. Try to spot the answer instantly. Do you see it?
Victory! It is absolutely option C. And look at how incredibly obvious it is now. The zero rule gives us our y-intercept immediately. Because the point is 0, 5, our c is exactly 5. The problem flat out tells us the gradient is 4, so our multiplier m is 4. Plug them into y equals mx plus c, and option C, y equals 4x plus 5, is the undeniable winner. Plus, because you know exactly how the formula works, you effortlessly dodge that sneaky swapping trap sitting right there waiting for you in option D. So the absolutely crucial takeaway here is that mastering these fundamental linear equations isn't just about passing one multiple choice test. It's about building a rock-solid foundation for much higher math. Which brings us to a final pretty provocative thought. We know a gradient of 0 means a perfectly flat horizontal line, right? But did you know that in advanced math, a gradient of 0 is actually used to find the exact turning points, the maximums and minimums on complex nonlinear curves? So how might mastering these simple linear rules today unlock the secrets of complex quadratics and calculus tomorrow? Think about that and keep exploring.
As always, the link for this study tool is in the description below. Let me know what you think in the comments.